A bad day fishing is a better day than a good day at uni. But not all fishing is sustainable and as peaceful as it is. According to FAO, nearly 90% of the world's marine fish stocks are fully fished or overfished as far back as 2011. Globally, it is estimated that 2.2 trillion fish are caught annually, with 30% or 660 billion fish being caught illegally, unreported, and unregulated. Today, we explore how the Sustainable Development Goal 14, life underwater, and further explore 14.4, sustainable fishing. We look at the molecular biology and how it can help turn this around and why this should be at the forefront of everyone's mind.
SDG 14.4 is focused on effectively regulating harvesting and ending illegal, unreported, and unregulated fishing, all collectively known as IUU fishing, and restoring fish stocks to levels that can produce maximum sustainable yields so that we can enjoy the catch of the day cooked up on a barbie.
This is critical. The Global Ocean Commission reports that 87% of the world's marine fish stocks are fully exploited, overexploited, or depleted. This is not good. Many large species, such as the bluefin tuna, sharks, and the blue wahoo, are below 10% of their historical levels and may soon reach tipping points where recovery becomes impossible, and beautiful days like these might not be as enjoyable.
Despite overfishing, countries still grant at least $45 billion a year in fishing subsidies, most of which encourage unsustainable practices, and fuel subsidies are the biggest part. Developed countries provide 70% of this, with Japan, China, the EU, and the US as the highest spenders.
Nearly 10 million tonnes of fish are caught annually in the ocean alone, valued at about $24 billion AUD. Illegal and unreported fishing is worth around $1.9 billion a year, especially affecting high-value species like the bluefin and sharks. Meanwhile, human population growth and rising demand for seafood are pushing catches even higher. Around 38 million people are directly employed in the wild seafood sector, and about 10% of the world's population relies partly on fishing or aquaculture for their livelihoods.
DNA testing is also being used to crack down on IUU, illegal, unreported, and unregulated fishing. By sequencing fish fillets at markets or ports, authorities can detect if endangered or illegal species are being sold. This science-based approach supports fair regulation and protects fish stocks for the long term. There are 3 basic steps for PCR reactions. The first step is denaturation at 96 degrees Celsius, where the heat reaction is used to separate DNA strands to form a single-stranded template, critical for the next step. The second step is annealing. This is done at 55 to 65 degrees Celsius. This cools the reaction so the primers can bind to their complementary sequences on the single-stranded template DNA. The third step is extension, reheating at 72 degrees Celsius so the Taq polymers extends the primers, synthesizing the strands of DNA. This cycle is then repeated 25 to 36 times. PCR use shows the rapid cycling and amplification of DNA sequences, which can be used to 1. Identifying species, if the fish was a species that is illegal to catch, or if the fish is protected, thus being illegal to harvest. Trace of origin, the DNA sequences for different fish can be linked to their geographical location. This is crucial for the identification of fish caught in prohibited marine habitat waters. Thirdly, the use of PCRs can also provide genetic material for other crucial analyses, like gel electrophoresis, to confirm illegal catches and trace the identity of the perpetrators.
Neglect fishing practices lead to long-term population degradation, habit loss, and overall destruction of aquatic ecosystems, causing future consequences of food insecurity in a growing population and unstable employment for 2.6 billion people worldwide. Scientific innovation will become centerfold in ensuring sustainable techniques are developing healthy aquaculture strategies. These advantages include the portable field DNA sequences, in which genetic materials shed by fish species can be collected to observe biological diversity and migration patterns for data analysis, identifying endangered species and detection of illegal fishing. An emphasis on ethical aquaculture also has the ability to solve overfishing by creating a controlled environment which alleviates pressure on the amount of wild fish and endangered species caught.
The conservation and restoration of our aquatic ecosystems are vital to sustain the human population. The SDG 14.4 conveys the importance of a cohesive effort and scientific advancements to create proactive strategies to identify illegal practices as well as cultivate species populations. Sustainable fishing isn't just about catching less, it's about using science, especially innovations in molecular biology, to make sure fish stocks stay healthy for generations to come.